My name is Frederick, and I am a platform engineer on the Cloud Foundry team at Pivotal. And what that means is I'm on the engineering team for Cloud Foundry, but field-facing, so I spend time with customers, talking to them about Cloud Foundry and helping them adopt Cloud Foundry. So that's my day job. In my spare time, I help on the Java enablement side of Cloud Foundry, working with Ramnivas and others on helping to make sure that Cloud Foundry is the best place to run Java applications.
And I'm Ramnivas. I have been with Spring, doing Spring development for a very long time now, over 8 years. And recently, before doing Spring Cloud stuff, I was associated with Cloud Foundry, the first version of it, V1, where I led the framework integration team. So that provided support for Java and Node.js and Ruby and all sorts of frameworks. Recently, I am started this new project called Spring Cloud. And what it is about is to make sure that Spring applications and even general JVM applications can work effectively on Cloud Foundry. So in this presentation, we are going to start with Spring Cloud basics. So one thing, before I do that, so name change, right? So earlier Spring Cloud was called what is today called Spring Cloud Connector. Essentially, Spring Cloud now grow in its scope, and it does address other parts of cloud needs. So not only service connection, service discovery, but other things such as circuit breaking and service registry and so on. So we're going to talk about here Spring Cloud Connector. So I'm going to start with Spring Cloud basics. So we're going to essentially divide into two parts. One, if you're a typical application developer, you will be dealing with how do I use Spring Cloud? How do I consume Spring Cloud? So we'll talk about Java config and XML config options. And then we're going to talk about a very neat thing in Spring Cloud, that's extensibility mechanism. And extensibility mechanism will come into play in two ways. One, if you have your own platform or your own services, or you want to extend beyond what frameworks we already offer, such as Spring Data, if you want to extend to other frameworks, then you will want to know about extension mechanism. But more interesting one is if you are going into microservices or if you are already using microservices, then even as a developer doing applications, regular applications, you can use Spring Cloud's extensibility mechanism to make some fairly interesting code. Finally, we'll talk about Spring Boot integration. So if you are using Spring Boot, using Spring Cloud is extremely easy. You hardly have to write any code, and we'll talk about how we get that done. So let me talk about what does it mean for application to be deployed in cloud environment. So here is your application, Java application, let's say, and you are deploying into some sort of cloud container. So in case of Cloud Foundry, it's going to be a DA, droplet execution agent. In case of Heroku, it will be a Dino. So some sort of container which is capable of running your application. When that happens, there has to be some communication between application and container. And that communication comes into two forms. One is it has to supply, the container has to supply application instance information to your application. Like, where is this application running? What is its application ID? Are there any limits on how much memory can it use, file descriptor can it open, and so on. And you will typically bind a variety of services to your application. When you bind that, it also needs to expose that service information. How do I use this service? How do I connect to these services? And are there any limits on those service connection? And then that information is going to be exposed to application. And application is supposed to take all this information together and make its job, do its job. So in case of Cloud Foundry, the first part, the application information, instance information, comes into form of VCAP application environment. So it looks fairly complex JSON, but some interesting parts are there are limits exposed there. So memory in this case, I can use 512 meg. I can use 1 gig of disk, and I can open 16K file descriptors. And there are a whole bunch of other things, host and port, and when did it start, what its name, and so on. On VCAP service, the services side, the service info, it is done through an environment variable called vcap services. So in vcap services, in this case, I am binding to a Postgres service with a specific vendor, Elephant SQL, and binding to a Redis service with Redis Cloud. And it exposes information such as URI, maximum connections I'm allowed to connect. And in case of Redis, there is no URI, but there is host and port and password. Things change between cloud vendors, cloud platforms. So in this case, Heroku does not expose as rich information, and we'll see the implication of that as we proceed through. So it only really exposes port to which your application is bound and the application ID through a variable called dyno. Services, it exposes, rather than exposing just one environment, it exposes a bunch of them. So it will expose, for example, Heroku Postgres purple URL, and the purple changes. There are a bunch of colors there, and they have each different characteristics. And for Redis, there are two vendors, Redis to go and Redis Cloud, and it exposes URI that signify which vendor it is coming from. Now, both formats have some advantages and disadvantage, right? This looks easy, right? It's just a basic environment, whereas in case of vcap services, it was JSON. That means you have to parse JSON to extract information that you need. But here also there are some implications. So now if you want to say, well, what are the Redis services bound, then you need to know very specifically what are these environment variables. So if new vendor joins in, then you have to kind of get awareness for that vendor as well. So there's a give and take there. So what does Spring Cloud has to do with all of this? Spring Cloud's goal is to abstract over these possible differences. It wants to say from application perspective, it should not matter how is that data exposed, what its format, does it change between versions. Application should not be concerned with it. It provides implementation for multiple clouds, Cloud Foundry obviously, Heroku, and through a community contribution, we also have support for local testing environment. So you can simulate cloud on your Mac or any machine and use it. It also provides extensibility without modifying code. So while it's open source project, you can contribute, you are welcome to contribute. You don't have to. So if you want to extend it and keep your extensions private, and there are actually very legitimate cases for keeping your extensions private, you can do so without ever contributing back to Cloud Foundry, Spring Cloud connector. So let's talk about it from user's perspective. If you are developing application and you want to use Spring Cloud, so what are you going to do? Two options, Java config, preferred option, in my opinion nowadays, and there's an XML option, we'll talk about it briefly as well. But before I do that, let me talk about auto reconfiguration. So who has attended Cornelia's talk earlier here? Okay, quite a few. So she talked about auto reconfiguration. Auto reconfiguration itself uses Spring Cloud underneath. What it does is, it's when you push an application to Cloud Foundry and bind services to it, and you have in your application certain beans, it does essentially matching, saying, okay, you have a data source bean and you have a data source service, Postgres or MySQL or Oracle. And it says, all right, if there are certain conditions that are met, if there is only one bean of data source type and there is only one relational data service bound to application, then I'm just going to automatically swap the original bean definition with the one that is associated with the service. And it does same thing for Redis and Mongo and so on. So the idea is, if you are developing application that is supposed to be deployed locally, you deploy to locally, local Tomcat, connecting to local services, it all works. And then you take the same WAR file or Spring Boot jar and push it to Cloud Foundry. You want it to just work. In my opinion, that initial experience is critical. Because if you push application and it just works, you actually start to believe that this Cloud Foundry or Heroku thing, I mean, Heroku doesn't have auto reconfiguration, but whatever that thing is, if it just works, then all right, now you are ready to pay the price of learning precise mechanism to get it working effectively. But you don't want basically to spend 3-4 hours to say, now that I have locally running application, I'm going to spend 4 hours and go to Cloud Foundry. that should be a few minutes process at most. And that's the goal behind auto reconfiguration. All right, so you do auto reconfiguration, and now I say, all right, I believe in Cloud Foundry, application is running, I see that. I want to do a little bit more with it. I want to make it work with cloud environment in an optimal manner. So first step would be to use Cloud Scan. So all you do is you create a configuration like this, and you don't have to have a special class. You can just tag on to any existing class. And you simply add Cloud Scan annotation. What it does is it scans your services bound to your application, creates a bean for each service, and puts it into your application context. It additionally creates a bean for application instance info and puts it into your application context. That means now if you do auto wiring, then these beans will be available for auto wiring. So there will be, let's say, a data source bean and RabbitMQ connection factory bean. And if you have auto wiring on those types, it will just work. So it's a step up from auto reconfiguration, but not all the way through. So all right, you will get, this will work in typical situation. But you might want to say, all right, that's fine. It did something. It created some default beans for data source and RabbitMQ connection factory and so on. But I kind of want to take control over it. I want to, so that I can make it effectively work in Cloud Foundry. If you want to do that, you extend this abstract cloud config, and you create beans using the API offered by abstract cloud config. So in this case, I'm creating a data source by saying connection factory data source or connection factory MongoDB factory. In this case, it is expecting that there is only one data source candidate service, so one relational service of any kind, and one MongoDB service. If it is multiple, then it won't work. And we'll talk about how to make it work. Right? So singleton services. So now if you have multiple services of the same type, so let's say two MySQL services, or one MySQL and one Postgres, basically services that could be converted into data source, that could be transformed into data source. So if you just say data source without any parameter, then it has to be only one service. It can't know which one you expected. But if you did expect particular one, then all you do is provide the service name. And it will bind now to, in this case, inventory service, the first bean, and the second will be customer service. That is still fine. This is, by the way, this is the case auto reconfiguration wouldn't have worked. If there are two data sources, it cannot, the same issue arises, is which it won't know which one it should swap with what. All right, this is what we are really leading up to. So if you are deploying to cloud environment, you want to take advantage that there are some specific opportunities and specific constraints that you have to follow. So in this case, you are saying, I want to have control over my pool configuration. So I want maximum 20 connections with wait time, max wait time to be 200. And I also want to have some connection configuration, character encoding, and some other things. So I create that, then I create a data source config based on those two, pool config and connection config, and then use my data source API, except instead of giving just the name of the service, I also give the configuration through which it should be created. Yes, question? So the question is, do you want developers to configure pool and such? Yes and no. We strive to give you good defaults to begin with. But there are cases where you may be sharing, for example, same service across multiple applications. And there may be constraint on maximum pool, for example. And you might want to say, well, let me divide up based on application characteristics. I may want to give, let's say there are 20 total maximum connection limit. I might want to give 15 to one and 5 to other. So in that case, you start to want to control that aspect. And maximum wait time, for example, is another one where you might want to, based on, so for example, if you're connecting to local, and if you're, let's say, deployed to a private cloud and you are connecting to a local data source, then max wait time can be very small. But if you're connecting to something out there, then it has to be appropriately high. So while Spring Cloud Connector will try to give you good defaults, you will have to like tweak once in a while.
And if you did want the operators to have more control over that, you could just put those parameters in environment variables, which you can then read in as Spring properties, and you could read them in that way if you wanted to get them out of code and into the environment somehow.
So Cloud Foundry gives, sorry, I don't know why I keep saying so. I've been giving Cloud Foundry talk a lot, so I keep saying that. But Spring Cloud gives support for all Cloud Foundry services, such as data source, RabbitMQ, MongoDB, SMTP, and so on. And this is especially important in private PaaS. So Cloud Foundry, as Cornelia talked about, it's open source platform as a service, and you can take it and run it in your own data center. You can have your own instances. Now, when you have your own instances, you will want to have your own services be available as a part of the solution. So for example, let's say, hypothetical scenario, you have some sort of search service available only in your cloud. Now, Cloud Foundry, Spring Cloud does not support by default search service. I don't even know what that service is, but let's say there's some service like that. Then, to connect to such possible services through extension mechanism, we offer a generic service API, which takes similar parameters, the name of the service, and in this case, the destination type. So I will like basically that service to be transformable to the search type. If so, then give me back that service.
Okay, so now we're going to show you what that actually looks like in code.
Yeah, there's a question. Go ahead.
Oh, sorry.
Going back to your previous slide, I asked this question in the previous session as well. Can you elaborate more on what's happening behind this? So let's say the search service, there could be multiple instances of that, right? So how is that, how do I get a search? So there are 10 services running, you have a cluster of how do I get a search, and how is the load balancing working?
Okay, so the question is, let's say if there are 10 services. We need to qualify what you mean by multiple services. If you mean multiple services that are themselves clustered, then it's not a concern of application. From application's perspective, there's only one service. There's only one entry point. But if there are indeed 10 services bound to your application, then the first string, the search service method, the string, signifies which service you are trying to connect to. As far as load balancing is concerned, if now in the earlier case where there is only one gateway, but there are possibly a cluster that is running behind it, then it's really the service broker's job, service provider's job to figure out how to do load balancing. Again, it's not your application domain's issue.
Okay, so now let's jump in and look at some code. So if you were in Cornelia's talk earlier, she was pushing applications live to Cloud Foundry. We actually took the easy way out and pushed them ahead of time. I think she's going to call it the coward's way out, but we're going to claim it was for expediency and call it the easy way out. I know she's not that mean, so she's shaking her head. So here's the steps that we did to push this first application to Cloud Foundry, and we're using Pivotal Web Services. And we're doing this demo first because my friend Vic gave me a free t-shirt out on the Pivotal Lounge. So we're going to use his service first, which is our hosted Cloud Foundry called Pivotal Web Services. So we built the project with a Gradle build file. So all that does is generate a jar file so we can push. In this case, it's an embedded container inside the jar file. And then we created a service, and this is a MySQL service that's hosted on Pivotal Web Services so that my app has a database to store some information in. And then I'm going to push the application. And when I push the application, it's using the manifest file, which is the little box over on the right, that's going to specify what the name of the application is, what route or URL I want to give that application, where the jar file is that I want pushed, the fact that I want this application to use this cities DB service that I created in that cf-create service line. And then I'm going to set an environment variable so that it knows it's using a cloud profile using Spring profiles. So that's the steps that we took to push this app. So let's go look at the app now. So it's at cities-s12gx@cfapps.io, which is the URL that I gave it in that manifest file. Let's just go to the very root of it. So what you're going to see here is this is a app that's exposing a RESTful endpoint. So this is a microservice that's purely exposing data in a database via a RESTful interface. So let's go one level down in the hierarchy here. And the first thing you might notice is all this link stuff at the top. So this is generating full hypermedia links into this data. So you can see I have a link. Let's go to the bottom first. So this content is also being paged. So I have a total of just under 2,700 elements that I'm getting returned from this service. But I've told it I only want a page size of 20. So it's going to give me the first 20 and tell me that there's a total of 135 pages and that I'm on page number 0. So then with these links at the top, I can see that the next page is going to be page 1 and my size is still 20. If I click that next link, then I'll also get a previous link. It's giving me a self link, and then there's this search link also that I'll show you in a minute. So this is hypertext, hypermedia links being generated in this REST output so that it makes it very easy for a client to be able to navigate through this data without having to manufacture URLs. All the URLs you need to navigate through this are right here in these hyperlinks. And then in this content structure, I have the actual data coming back. So the domain for this application is a list of postal codes in the US cities for those postal codes. It was a very easy data set to go out and find. So what you'll see I have is the name of a city, the county it's in, the state, and the postal code, and then a latitude and longitude. And for each of these elements, it also tells me what the link to that element is. So if I want to go directly to that element, I just have to navigate to that link. So obviously the goal is to navigate through this programmatically. We're just kind of showing you in a browser what it looks like so you can visualize what's going on here. So that's what the code, well, let's do search before we leave here. So you see that I have this search link, and I'll just click on that in the browser. You'll see that I have several options to be able to search for this data. So for example, I can search this database by name. So I'm just going to generate that search. It actually generates these links using this templated form, which the browser doesn't always handle very well, but it makes it very easy to parse them programmatically. So I'm going to build this by hand. So I'm going to try to search by the name of a city. And the query I want to use is Dallas, since that's where we are. You see that when I generate that, it's still giving me the next and self link. So this next link is now going to go to the next page that still adheres to this search. And now all I have is cities that have the name Dallas somewhere in their name. Okay, so that's a demo of what the app is doing, and now let's go see what the code actually looks like to make that happen. So this is a Spring Boot application. I think that's our first mention of Spring Boot, isn't it?
Yeah.
That might have been too long. We might have tried to get that in there sooner.
Yeah, our bonus depends on how soon we say Spring Boot.
Yeah. So Spring Boot application, and this is the entire bootstrapping code for the application. Some interesting things here are we're, of course, using the Spring Boot auto configuration. I'm also using this annotation that comes from Spring Data, which is enabled JPA repositories, and another one that comes from Spring Data REST, which is the repository REST MVC configuration. So what these two annotations are doing is just causing a whole bunch of code to be pulled into my project. Of course, I've got the appropriate Maven dependencies for these starters also. And then I just have the typical Spring Boot application code. And the next thing I want to show is we have this domain class that models each of the cities, and it's pretty much exactly what you'd expect. I have an ID and a name and a county, a state code, a postal code, and the Latin long. And then this class just has JPA annotations on it. So very straightforward stuff, entity, column, that sort of thing. So now to get to the meat of it a little bit more, let's find the repository. So this class, you'll see it's actually an interface, and it's called City Repository, and it's extending this Spring Data interface called Paging and Sorting Repository. And I'm telling it that I want a repository that knows how to store these city domain objects and knows how to look them up by an ID, which is a long. And then I'm just implementing some methods of this interface. Find all is just going to get all records out of the backend database. And then I have these search methods like find by ID, find by name, ignore case, So this name contains is actually the one that I demoed. So I have this method called find by name contains ignore case, and then I just pass it a string. So that's an example of a search method. Then I have this class annotated with repository REST resource, which is coming from Spring Data REST. And I'm telling it I want the URL for this repository to be cities. And then each of these methods I'm annotating with the REST resource, which is going to build additional REST endpoints. So that's 3 source code files so far, the application class, the domain class, and this repository. So you may be wanting to see next where the code is that implements the Spring controller to actually do all of the HTTP request mapping and all that. It's all right here underneath this REST repository resource. All the code to initialize Hibernate to get it to do all the JPA stuff and handle all the annotations and do all the mapping from the database to the domain object. There is no code in this project for that. It's all right here in this class. All the code to marshal the domain object out to JSON using Jackson. There's no code in this project for that. It's all underneath of this REST repository resource. So this is all of the code. What's going to happen at runtime is Spring Data REST, since it's on the class path, is going to generate the actual Spring MVC controller with all the right paths and everything to hook all this up and make it do everything we were seeing it do in the browser. So that's Spring Boot and Spring Data and Spring Data REST. Just a little bit of a taste of all the power that's involved in all that. This isn't a Spring Data talk, this is a Spring Cloud Connector talk. And there's actually a session on Spring Data REST that I believe was immediately before this one. So if you're interested in more details about how all this stuff works with the repository REST resource and what's going on under the covers, and a lot more power. For example, these methods are completely free-form. I'm just making up the names of these methods, and Spring Data REST is parsing out the fact that it says name contains and ignore case and all that, and generating these methods on the fly. It's really, really powerful stuff. So once I've got the session recordings up, you might want to go back and watch the session that I think Roy Clarkson and Greg did it, first session this morning. So again, 3 classes, really powerful, reading from a database and generating REST endpoints from that. So the only piece that's remaining is telling this repository where to go get the data from, and that's where Spring Cloud comes in. So I have 1 additional class. So this is an at configuration class, so that means Spring is going to find it and use it to contribute more beans to the application context. That's what at configuration does. I'm telling it I only want this configuration to be active in the cloud profile, and then I've got 1 bean defined in here. And inside of this 1 bean, it's calling connectionFactory.dataSource. And this connection factory comes from the fact that this extends the abstract cloud config class. And that's it. So from that, I get a Java data source that's going to be a bean contributed to the application context that all the Spring Data REST stuff is going to find and use as its data source to go hit this database. So that's really, with some annotations, 1 additional line of code. So what's actually going on behind this line of code is everything that Ramnivas was talking about a minute ago. There's the VCAP services environment variable that on Cloud Foundry describes the MySQL service that was bound to this application. It's going out and retrieving that environment variable, parsing the JSON, pulling a connection string out of that JSON, along with pulling the name of the service and anything else that's interesting. It's taking that connection information, URL, username, password, and constructing a data source object from that, and then returning it from this method so that it can be contributed as a bean. And that's it. So 4 Java classes, a lot of power. You've got a full-blown hypermedia-enabled REST endpoint running on Cloud Foundry and hitting a SQL data source. Okay, any questions about that before we move on? Okay, so next, I'm going to not jump into presentation mode just yet. So Ramnivas already mentioned that we can use Spring Cloud to find services running on both Cloud Foundry and Heroku. So let's do exactly the same demo, but we're going to push this app to Heroku instead of to Cloud Foundry. So here's the steps that we did to push it to Heroku. We pushed the application. I'm specifying the build pack explicitly just because I've got both a Gradle build file and a Maven POM file in this project, and I want to force Heroku to use the POM. And then I'm setting this environment variable. Another thing that Ramnivas mentioned was that Heroku doesn't expose in the environment the name that you're given to your application. So we're just going to set that application name explicitly, and Spring Cloud Connector will look for this environment variable as a way to get that application name so that you can query that through the Spring Cloud API. And then just like I did with Cloud Foundry, I'm going to set the Spring profile active to cloud. Heroku will automatically provision you a Postgres database, but I just wanted to show this just to make it explicit that I'm getting a Postgres database automatically exposed to my application and running on Heroku. And then finally, I'm going to do the git push that actually pushes the application code up to Heroku. So now let's go out and see what that looks like.
Yeah, there's a question, yeah?
I'm sorry, say that again? No, the Heroku build pack does not do that. The Cloud Foundry Java build pack doesn't set that profile currently either. At least it doesn't under all circumstances.
Yeah, it does it for WAR applications. It does not do it for Spring Boot yet.
Yeah. Okay, so here's the same REST endpoint. You can see now it's running on Heroku. I can click down in there. I can navigate. I can start hitting pages. It functions exactly like it did on Cloud Foundry, even though it's running on Heroku. So let's go show you what the code looks like for that. So there's the code for that. It's exactly the same code, no changes. So what's happened here is underneath the covers, Spring Cloud has detected that it's running on Heroku, and it knows how to go find those environment variables exposing the Heroku database. In this case, it's a Postgres database instead of MySQL. Spring Cloud has configured the data source appropriately for the different database type even. So this is true cloud portability. You've got one set of Java code, push it to Cloud Foundry, push it to Heroku. It's going to inspect the environment and figure out what it needs to do. In this case, we're returning a data source. It would do the same thing if I was attaching to a MongoDB database or a Redis service or a RabbitMQ service or any of the other ones that Spring Cloud supports today. All right.
So I'll briefly talk about XML configuration. So who is still using XML configuration? Okay. Go ahead here. All right, I mean, if you have existing applications, so I can totally see the value of, continue to use XML configuration. But if you're starting a new application or if you got some spare time, convert into Java config. It's much more beneficial that way. All right, but I'll talk about XML configuration because Spring Cloud supports XML configuration. And it's really a mapping of what you saw in the Java config, right? So in Java config, you had Cloud Scan. Here you have a service scan. Actually, we have a service scan annotation as well. The difference being if application instance info is also registered or not. If you want to use explicit configuration, then you use Cloud namespace with data source or MongoDB factory, and there are a bunch of others, RabbitMQ and so on. If you want to provide service name, so in this case, 2 data sources binding to one or other service, you specify the service name. By the way, if you don't specify anything here, it expects one service of that particular kind as usual. And the bean that is created is the same as service name. The bean name is same as service name. But if you want to override it, you just provide an ID element, and ID will be then the bean, that will be the bean ID. So here you provide in service name. If you want to go and configure a little bit more, so in this case you want to say my pool size and my connection properties, then you use nested elements here to provide those values. If you want to connect to a generic service, then there is a cloud:service. That's the generic element that says, give me a service name, and I will connect to that particular service and create whatever connector it could create off of it. If you want to control what kind of connector you want to create specifically, then you can provide a connector type, the type that you are expecting this bean. In the earlier case, it will create it appropriate one, but you don't know which that appropriate one is. So if you want to force, essentially it's a search criteria, saying I want to constrain on both the service name and the destination type. So currently, Cloud Foundry, the services that we support include on Cloud Foundry and Heroku, MySQL, Postgres, Oracle, Redis, MongoDB, AMQP, RabbitMQ, SMTP. And in a branch of the same project, we also starting to support connectors that are available on PCF, Pivotal Cloud Foundry. So we start with Pivotal HT, and I will give a demo a little later of that.
And like Pivotal Web Services is Pivotal's publicly hosted Cloud Foundry. Pivotal CF is a commercial product that Pivotal sells for on-premises Cloud Foundry deployments where you're running Cloud Foundry on your own hardware in your own data center.
Right.
Yep.
Let's say you have an application you want to deploy to Cloud A and Cloud B. And Cloud A, let's say, provides Memcache, and B provides Redis. How would that be possible? Is it something configured in the abstract cloud configuration?
So the question is, what if there are similar but not the same services, like Memcache versus Redis? And in this case, I'm assuming you are trying to use as a cache, right? Because
Yeah, but I mean, I don't care about the implementation details. Let's just assume I hide those implementation details with that interface. So
yeah.
it's not important.
So what I would do is, in that case, so essentially you want to use it from, and then it's backed by Memcache or Redis, and you want to hide that detail from application. So assuming you have written such an interface that lets you work through this thing, the way I would do it is I would have that implementation take dependency on Redis and Memcache, but I would make, let's say, auto-wired and required to be false. So in this case, you are saying auto-wire a Redis or auto-wire a Memcache, but not require both to be, or even one to be available. And then you, based on what is bound to your application, you can go one route or other route. Alternatively, you can have two implementation, one with Redis and one with Memcache, and one of them is going to be based on profile or based on availability of service, some condition or something. So there are various ways to go about it. I think it's fundamentally from Spring Cloud connectors point of view, those services will be available to your application to be auto-wired or explicitly connected, and you will take it from there. Your implementation will lean on the fact of certain being available or not, and then you go from there. So I'm going to actually give a demo of Hadoop now. So it's running in a private PaaS, and I'm going to first show you the environment. So in this case, the command I gave was cf-env PCF demo. So I have bound two services to this application, a Hadoop service and a Pivotal Hadoop service, PHD, and a RabbitMQ. And you can see that the JSON is not exactly the easiest to decipher, because PHD is a complex service. It exposes, of course, Hadoop, but it also exposes Gemfire XT as a way to work with Hadoop, and a Hawk, which also acts as a JDBC, but kind of gives you RabbitMQ API. So you can see there is a URI for Gemfire, there is a URI for Hawk, which is Postgres-like. There is HDFS configuration, there is Yarn configuration. So a lot of stuff. Similarly, a lot of stuff for RabbitMQ. And you can start to see like Spring Cloud's value is to not have to let you deal with this thing, because it's complex, and it might change, and you want some layer to just absorb that difference. Anyway, let's talk about application itself. So what this application is, it's kind of e-commerce monitoring site, and orders are coming from variety of sources, and each order comes from certain state. And you want to kind of create a heat map of where are the orders coming from. So as the orders are coming from in some sliding window, you can start showing a different color to say where is the right now most orders coming from, and what's their gradation like. So underneath it uses, actually let me show you the code that kind of goes behind it. So this is an explicit configuration. This is what I'm using currently, but it's one of the interesting things about Spring Cloud is if you kind of distill it down, it becomes invisible. In the sense, there is a couple of lines of code in your application, if that. So kind of wanted to show the, not whole magic, but part of magic. So in this case, I have a cloud config, and I need 4 beans. One for RabbitMQ, one for Hawk data source, another one for Gemfire, and another one for the Hadoop part of it. Since PhD is a composite service, PhD is, itself exposes multiple services. The naming convention that we adopted, and this is still work in progress, is the Hawk service that is exposed under PhD, it comes as like a directory structure. So it's a Hawk part of PhD, Gemfire XT part of PhD. It's just since there are 2 relational databases available now, Gemfire and Postgres through Hawk, I have to give an explicit name here because again, the same problem, it wouldn't know which kind of data source you're looking for. I don't have to do it for RabbitMQ or I don't have to do it for Hadoop configuration because there's only one of its kind. Then when it comes to using it on the consumer side, I am auto-wiring 4 beans here. And so let's talk about last 2 first, they're easy. So I'm simply saying I want the configuration. In this case, the configuration class is imported to be Hadoop configuration. And then I'm giving a bean name and the connection factory for RabbitMQ. So that's easy part. The other 2 part, because there are 2 data sources in your application context, you have to wait to specify which one do you want. And you do that by giving a qualifier. Qualifier, it's just a Spring concept, dependency injection concept, that lets you specify something additional about it. So in this case, I'm saying the name of the bean should be Hawk data source or Gemfire XT data source. And where are those names coming from? They are coming from the method names. So by default, if I just say add bean, the name of the bean is the method name. If I want to override, I could have provided bean and name equal to whatever name I want to choose. So that's how you would do it. If you want to go to more implicit configuration with Cloud Scan, then the configuration collapses into one line, Cloud Scan. And you can again tag on to whichever configuration class that you may already have. You don't need to have an explicit separate one here. So this is it. This is all you have to do. There are no beans to be created explicitly. It would create appropriate bean. What changes, however, is on consumption side. So on consumption side, since the bean name is the same as service name, that's what you use in your qualifier. So in this case, the qualifier is PhD service / Hawk or PhD service / Gemfire XT. So you have to choose which route you want to go. If you are injecting these beans in many places, I would kind of prefer the former way of doing it because I kind of want to isolate my lot of classes from specific name of the service, right? The PhD service is the name of the service. But what if I want to change it to something else? I don't want to go and change all the classes. So explicit configuration would allow you to specify a generic name that makes sense from application point of view and make a decision of binding to a particular service right there, and nothing else gets affected. But it's a choice. It's nothing really, there is no hard and fast rule here, depending on whatever is appropriate for your application. So let's talk about now much more interesting part of it, which is really very specific to cloud, Spring Cloud. Actually, one point I want to, if you used Cloud Foundry like 2 or 3 years back, you've probably seen something called Cloud Foundry Runtime. Cloud Foundry Runtime predates Spring Cloud. It basically does the same thing. It had a Java config and it had XML config and everything, but it was not extensible. If you wanted to add an additional service, then you had to modify the code. And that's all fine as long as we were controlling the services. But as soon as we go into private paths, where you will bring in your own services or microservices, then that wouldn't really fly very far. So that's the reason we went with Spring Cloud.
Okay, so this is going to get into the internal design of Spring Cloud a little bit to talk about the classes you would need to write to add support for additional things in Spring Cloud. And first of all, there's really 3 axes of extensibility in Spring Cloud. There's 3 reasons why you might want to write new code to extend Spring Cloud. And the first one is you might want to support an additional cloud platform. So out of the box, the project right now supports Cloud Foundry and Heroku. Of course, there's lots of other PaaS platforms out there with Amazon, Elastic Beanstalk, and Google App Engine, and all sorts of things like that. So you may want to extend Spring Cloud to support some other cloud operating environment besides the 2 that it supports out of the box today. And then the second thing you might want to do is make it support additional services. Ramnivas listed the services that it supports today, including SQL databases, Mongo, Redis, Rabbit. There's a long list of other services that we plan to add support for in the project, like Neo4j and Cassandra and Couchbase and all sorts of things like that. You may have some needs like that to add support for additional services. And then the other main use case there is there may be services that are really specific to your company and your environment that would never make sense to contribute back to the core project, but you want to use Spring Cloud as a way to get to those. So those are examples of how you may want to extend on this services axis. And then the third one is framework support. So one of the core components of Spring Cloud today is this Spring connector. And what's in there is the code that knows how to create data types in the Spring data framework. So when you get a MongoDB type back from the Spring Cloud connector, what you're really getting is a Spring data MongoDB connection type. So there may be cases where you're not using the Spring data frameworks, you're using some other native drivers to get to those data sources. That would be cases where you'd want to add support for additional frameworks besides maybe just the Spring and Spring data view of the world. So this is kind of a diagram of the components that are inside of Spring Cloud. So the Cloud Connector is the piece of code that knows how to go out and inspect the operating environment to determine if it's Cloud Foundry or Heroku or something else, and then pull that data out of the environment, usually from environment variables, but it can really do whatever you want the code to do. And then the thing that your application actually wants to consume is the box in the bottom right, which is the service connector. That's the data source or the MongoDB factory or whatever the actual type is that your application wants to consume. And all the rest of the code is how to wire those 2 things together, how to go from a cloud connector that knows about the operating environment to a actual connection object that your application can use. So the first piece of that is what's called a service info. That's basically just a Java data model that models the data you need to know about a service. So it might be a URL, including a host and a port and a database name and a username and a password. That might be what's in a service info. If you're hitting a web service, it might be a URL and an API key. So service info is just the model object for the information you need to know about a service to connect to it. And then the thing that ties it together is a service info creator, service connection creator, sorry, which can take the contents of that service info, all the connection information, and create the right type of connection object from it. Okay, so if you want to extend along that axis of cloud platform extensibility, there's one interface you implement called Cloud Connector that has 3 methods in it, and they're all pretty simple. Is-in matching cloud returns a Boolean that just says, am I running on the platform that you are implementing support for or not? So in Cloud Foundry, this is-in matching cloud method basically says, do I have a VCAP application environment variable? That's unique to Cloud Foundry. That means if that exists, you must be running on Cloud Foundry. In Heroku, it looks to see if that dyno's environment variable is set, which is a Heroku specific thing. So on each operating environment, cloud operating environment, there's probably some environment variable that platform is setting that uniquely identifies it. And what this really allows, the reason that it's got this is-in matching cloud is you saw in that Cities REST demo, I was including both the Cloud Foundry connector and the Heroku connector in that project, and that allowed the code to run on either one. So what the Spring Cloud core code is doing at startup is it's looking at all the cloud connectors that have been included in the project, calling this is-in matching cloud on each one, and the first one that says, yeah, you're running on the cloud that this class is meant to support, then it goes on and calls these other methods. So get application instances info just returns the raw information about an application. So it might be the name and what other information does it pull out? Yeah, the host and other information like that. And then the get services infos is kind of the biggest method. It's what goes out and pulls in all the service information you can possibly find out about. So all the bound services are going to be inspected and populated into this list of service info objects. So again, these service infos are the description of each service and how you connect to that service. So this method is responsible for going out and pulling all that out of the environment and providing it in this list. So all of this Spring Cloud internally uses this Java service loader mechanism, which is really nice. This was a brilliant move on Ramnivas' part to design this into Spring Cloud. So once you're writing any of these components that you want to extend Spring Cloud with, the way that you register them with the Spring Cloud core is to use this Java service loader mechanism. That's a part of the JDK. So you can create a file underneath this meta-inf services directory. So the meta-inf in the services is dictated by the Java service loader mechanism. And then Spring Cloud will look for a file called org Spring Framework Cloud Connector. So you would list any of those Cloud Connector classes that you write in that file. So again, there's 2 sub-projects in Spring Cloud right now, one for Cloud Foundry, one for Heroku. In each of those sub-projects, they have a copy of this file with one line in each of those that just says, here's the class that implements the connector for this cloud platform. Okay, so let's go on to how you extend Spring Cloud to talk to additional types of services. So we've talked about service info already. It's an interface with just a base amount of information, which is the ID or typically the name of the service. So that's the minimum amount of information you need to identify a service. Your subclasses or your implementation of this interface are going to include all those other fields like host and port and database name and username and password or whatever other information you need. So you would implement that interface and just add fields with getters and setters to it basically. And then you need a service info creator class. This is the class that knows how to go to the service information that the cloud provider gave back and map it to a service info. So this is basically pulling out of, for example, VCAP services environment variable and building a service info from it. So you'll need an instance of this class for each cloud provider you want to support because that mechanism for how you parse the service information out is different between Cloud Foundry and Heroku. So you would need potentially a Cloud Foundry version of this class and a Heroku version of this class. And it's got an accept method, which is similar to the isMatching cloud method in the cloud platform. It just says, are you a service info that knows how to create this type of service? And then the meat is in the create service info class, which actually parses the environment and creates the service info from that. And we're going to get into examples of what each of these look like in code here in a minute. So you register new service info creators the same way you register cloud connectors. So in your code where you're creating this service info creator, you would also create this meta-inf services file, and Spring Cloud is going to know actually the Cloud Foundry connector in Spring Cloud is going to know to look for this class called org.springframework.cloud.cloud-foundry service info creator. So for example, the Cloud Foundry connector that's already built into Spring Cloud, this is what its file looked like. It just lists all of these service info creators for all the services it already knows about. So you would create a similar file and just add your classes to it. So then the third axis is, yeah.
Can you go back to this slide? So the actual,
Yeah, let me do the build here.
Yeah. I guess I'm surprised to see that the name of the service in the meta-inf is Cloud Foundry specific. I would have thought it would have been a generic name and it would have contained the list of classes that describe each of the service info creators. But so is it really literally Cloud Foundry service info creator and that was somehow special? And if I had other ones for other services, or is this basically if I have a Cloud Foundry service adapter and I have a Heroku service adapter, I'd have one for Cloud Foundry, one for, and then these are the service info creators for each of them.
Exactly that. So the question is, why is their name Cloud Foundry Service Info Creator in that meta-inf services line? And you can answer your own question right there at the very end. So this is being read by the Cloud Foundry connector inside of Spring Cloud. So the Cloud Foundry connector is going to go look for this Cloud Foundry Service Info Creator file and register any service info creators that know how to parse from VCAP services into a service info object. Those Heroku implementations of these classes are going to be looking at the flat environment variables and populating a service info from there. So again, these classes are what maps from whatever the cloud operating environment looks like to this kind of normalized data model that is the service info classes.
Yeah. Sorry, what? All right, so that's, in fact, that connects to the earlier, what was Squatter answer. The reason is we need a separate implementation of a Cloud Foundry than Heroku is because the service data representation is different. So in case of Cloud Foundry, that SD parameter is bound to a map because essentially it's a JSON, objectified JSON. Exactly, and as long as the implementers have to now know that they expect a map and they know how to look into how to decipher that map. Whereas for Heroku, it's actually a pair. It's an environment variable name and the URI, and then it has to know it. I mean, Scott and I was talking yesterday. Is we are looking into a way if we can normalize it. So essentially, along with platform, you provide a normalizer. But it's kind of always an issue, right? Normalizing is not exactly an easy mechanism because we have to look into all the possible use cases and saying, like for example, what would it mean to normalize a Hadoop service? It's such a gigantic service, and can we give it in such a way that both platform can understand? So we don't know yet. So right now we took a path where saying the info creator, usually it's not everything is like a 3 or 4 line of code because there's an abstract class that takes care of most of the hard work. But yes, that's the difference we have because we kind of want SD to absorb the platform specificness.
Yeah.
Correct. The question is if you want to support, let's say, SMTP service on a new platform, then yes, you will have to implement a specific one. Unless it is very close to one of these two, then you can just extend it. But you will have to list it nevertheless.
So for example, this is listing the Cloud Foundry example. So you see these package names have cloud.cloudfoundry.mysql service info creator. There's complementary classes of each one of these for Heroku that knows how to take the Heroku flat environment variables or just key value pairs and parse the information out of them. So if you were going to go provide support for another cloud environment platform, you would do that cloud connector class, but then you would probably go and implement as many of these as you needed on that other platform as well. So it ends up being a number of classes, but like Ramnivas said, each of these classes is really, really small. It's the bulk of the code is in one method, and that method is typically just either getting something out of a map or getting something out of an environment variable, parsing it and shoving it in a data model. And we'll see examples of what that actually looks like here in a minute. Okay, so again, the third axis of extensibility is framework. So if you didn't want to use Spring Data's way of getting to MongoDB or Spring Data's way of getting to JPA, you may want to do something else. You would create a new service connector creator. So this is the code that maps a service info, which is again the data model for how to connect to something, to the actual connection object. So in the case of the Spring Data JPA, it's just going to take the host name, port, database name, username, password, and pull all that out of the service info and create a data source object from that. So 3 methods. The main method is the create method that just takes the service info data model and returns the appropriate connector type from that. And then the other 2 methods are just informational methods, just so Spring Boot can, or Spring Cloud can get information. So yeah, I think that's it on that. Yeah, question? Out of the box, it's just supporting Spring Data JPA right now. It doesn't do JDBC template.
Yeah, I mean, Spring Cloud, right? Spring Cloud, it really supports only data source, which you may inject into Hibernate or JDBC template, wherever you want. Auto reconfiguration, on the other hand, is, it supports Hibernate and JPA. And that support really means it's changing the dialect. So for example, if you're locally connecting to H2 database, and your service is bound to MySQL, then you want dialect to be changed to MySQL. So that's all there is really to it in case of auto reconfiguration. Spring Cloud doesn't concern with how do you use those services eventually.
Okay, and then the last point on the framework extensibility is, of course, you have to register any of those service connection creators that you write, and you do that in exactly the same way using the Java service loader mechanism. So you'd create this file that's the service connection creator file, and then add all of your service connections to it. Again, these aren't specific to the cloud platform, so you'd only write each of these classes once for each type of connection that you want to create. Okay, so let's get into the demo of that.
So one thing I want to add before Scott goes to demo is, so Spring Cloud, when it started and initial its implementation is really, it was about extensibility, but by extensibility we really generally meant services as we kind of imagine, like data source and MongoDB and SMTP and Hadoop and etc. But then comes along microservices, right? And then we call it microservices, right? So shouldn't microservices look like any other service? So for example, why should a shipping service or inventory management service look that much different than data source, right? They are ultimately, they're all services, right? They all should behave, look the same. So Spring Cloud's extensibility actually came into play very nicely here, because we didn't add extensibility because we were, we don't want to implement all the connectors. But there is reason for that as well. There are legitimate reasons for that. But more like there are cases where we cannot add those implementation. So for example, if you have a shipping service, we cannot add an extension ourselves because we don't know how your shipping service looks like, or any other microservice that you may have. We do not know how it is going to look like. So you should be able to add extensions yourself, and it should play along other services, what we traditionally call, let's call traditional services, just the same way. It should be uniform access there. So that's this demo is going to show is, it's going to be not look very different than the services that we talked so far.
Yep. So similar to what we were doing with the backend code, we've got a Java project here. We're going to use Gradle to build it. In this case, it's going to generate a WAR file instead of a jar file. There's really no good reason to do that other than to do something different. And then the second line is the interesting one. There's this concept in Cloud Foundry of a user-provided service. And all that means is you're not asking Cloud Foundry to go provision some service for you, like a database or a RabbitQ or anything like that. All you're doing is telling Cloud Foundry, for the sake of apps running on Cloud Foundry, here's something external to Cloud Foundry that an app can talk to. And that's what a user-provided service is. So I'm going to create this user-provided service in this second line, and I just get to decide what parameters you need to talk to that service. In this case, I need a URL to talk to the backend that we demoed earlier, because what I'm building is a web GUI front end to that backend. And then I'm going to add this other field, tag, just so I know what this REST endpoint is that I'm talking to. I may be consuming several REST endpoints, and I need some way of knowing which one is which, basically a way to name those things. And then I'm going to push the application using the manifest that's in the lower right-hand corner. So I'm going to give it a name. I'm going to give the app a URL, the path to the WAR file, and then you can see that I'm referencing the cities-ws service that I created in that CF create user provided services line. I'm going to bind that service to this application, and so I can consume it in this front-end application. Okay, so let's once again show what it looks like first. Oh, you need to, okay, just need to refresh. Okay, so this is what the app looks like. This is an Angular JS HTML plus JavaScript front end talking to a Spring MVC backend. And all it is a web UI that's exposing all that data coming from the backend service. So I implemented one search here, so I can search for Dallas and just get all the cities that have Dallas in the name. I've got some paging controls down here at the bottom to show off the hypermedia navigation. And then there's a link over here you can click on to pop up a Google map for that postal code. So that's what's going on in the front end. Let's see what the code looks like for that. Okay, not surprisingly, this is a Spring Boot application. So there's my startup code. I'm using the enable auto configuration. I'm also using this enable Spring data web support. That's basically just going to pull in some classes that make it very easy to marshal the JSON into Java objects. That's really all I'm getting out of the Spring data web support annotation there. Because I decided to package this as a WAR file, I need one additional initialization class that just initializes the servlet. Again, it's not doing anything special. It's just the base Spring Boot servlet initialization class. If I had chosen to bundle this as a jar file, then I wouldn't need this class. And then I've got a controller, a very typical Spring MVC controller that's mapping to the city's endpoint. So this is the endpoint that the AngularJS front end is going to hit inside of its own back end. And I'm providing 3 getters on there. One just to get all of the cities that are in the database, and another one to search by city name, which I did in that form field box. So this is really kind of a proxy controller. This is just taking the requests from the AngularJS front end and forwarding them on to this repository class where all the real work is being done. So let's find that repository. I'll show too that it's the same city data model with the same fields and the getters and setters as we had on the back end. Then the city repository is where all the real work is going on. And what we're using here is this library called Feign, like you'll see here. That's the spelling of it. This is part of the Netflix open source stack. And I believe in Dave Sire and Spencer Gibbs' talk this afternoon, that's one of the components they're going to talk about in their talk that is something like Spring and Netflix OSS together. So this is a really nice little library that makes it easy to create code that will call some back-end REST endpoint and do all the HTTP calls for you, automate the marshaling of the responses back to Java code. It really, to me, feels very much like the Spring Data REST, the way that it automates code to talk to some database, but it's doing it kind of at the other end where you are trying to write code that's going to consume a REST service. So this is just Spring's repository interface. I could have used that component here just as well. I just kind of like the repository semantics. But this request line annotation is kind of the important part here. So this is an interface. I have 2 methods. One to get all entities out of the back end by a REST call, and the other one to do a search via the REST call. And you can see that these 2 URLs in here are the URLs that I was showing in the browser to get to that back end. So all I have to do is annotate these methods with this @request line, which comes from the Feign library. I love it when Eclipse keeps putting up those help bubbles, or not so help bubbles. So I'm just annotating each of these methods with what back-end REST microservice URL I want to be invoked to go get the data and whatever parameters I want to pass. In this case, I've implemented the paging, and I can specify from the front end how many entries I want in each page. And then in the search one, I'm invoking the search endpoint with the name contains, specifying the name as a search parameter, and also the page and the size. And in terms of, well, there's one other thing to show. So now that you've got this interface, you don't actually write an implementation of this interface. Just like with Spring Data REST, you don't write an implementation of your repository interface. The way that you actually hook this up and get it to run, I'm just going to show an example of what this might look like if I were just hard coding this. So you have this Fluent API that Feign provides that allows you to say, I have this city repository class with those annotated methods, and here's the URL that I want you to hit underneath to go fetch the data and populate the, generate that city repository class from. You can specify decoders and encoders if you need to do special stuff to the data model to get it to the over-the-wire representation or the over-the-wire representation back to the data model. In this case, there's nothing special to do. I'm just letting Jackson do all of the encoding of the JSON back to the data model. So this is what I would do to create this if I was just going to hard code this. But again, this is a Spring Cloud Talk, and what I want to do is show how I might get this URL out of the cloud environment and have this Feign builder automatically run and just give me a city repository back. So let's see what that would look like. So basically all this code I've shown so far is really application code, and now we're going to get into the Spring connector part of it. So the first thing I wrote was this web service info. So remember, service info is the thing that you need to pass to a connection creator so it knows to create the right type of object. In this case, the only thing I really need out of my bound microservice is its URL. So I'm going to extend this base class that's already in Spring Cloud that's a URI-based service info. So I've got a URL field, and that's really all I need to get out of here. So now I need a way to, on Cloud Foundry, read the environment and build this web service info object from that. So for that, I need a service info creator. So this is my service info creator for Cloud Foundry. If I wanted to deploy this app to Heroku, I would again write a different implementation of this. So what it's going to do for Cloud Foundry is I have an accept method here. So I'm going to look at those credentials that were in that user-provided service that I created and then bounded this app and just pull those credentials out. So really the way I'm identifying that it's the service I care about is by that tag I added on the user-provided service, and I'm just checking to see if that tag is equal cities, which is what I was expecting. So this is really, all this code in here is really just drilling down into a hash map that's given to me by the Cloud Foundry provider and pulling fields out of that hash map.
It's not necessarily that URI always refers to a service deployed on Cloud Foundry. You can do that.
Correct. That's a really good point. So it doesn't really matter that this backend service I'm trying to talk to here, that this URL refers to something on Cloud Foundry. In this case, I'm demoing a front end talking to a microservice with both deployed on Cloud Foundry. I could have the front end deployed on Cloud Foundry and the back end running on Heroku. It would just be a different URL I would provide in that user-provided service link.
Or it may be URI that you haven't even deployed, Google Maps or some other URI. It doesn't matter really.
Yeah, so in the case of Google Maps, you might have the URL and an API key. So it might be a little bit different web service info, but you do it exactly the same way. So then once I've told Spring Cloud that this service has the right credentials that I care about, I just need to create the service info object. So all I'm doing here is navigating down through the map that the Spring Cloud connector for Cloud Foundry provides to me. So there's a credentials, it's just a helper method here. There's a credentials field in that map that contains everything I put in that user-provided service. I'm just going to pull that out, and just for the fun of it, I can support either a URI or a URL as the key to the URI that I'm going to get back. And then I'm just going to populate this web service info with that URL. I'm also getting the name out of there, and really the only reason for that doesn't have value in this demo, but when Ramnivas was talking about some of the cloud scan stuff, when it's going out and scanning for services and it's automatically creating beans, it'll name the beans based on the name of that service you created. So it's always a good idea to populate the name part of or the ID part of the web service info as well. Okay, so that's the second class. And then the third class is, let me find the right one. Okay. I'm not finding the.
Web service info, why couldn't you just use its base class direction?
Actually, it could have been done, yes.
Really just as an example.
Okay.
So you may want other fields in there.
In general, here we wanted to basically show what would be the full spectrum of things you will have to typically do. In this case, yeah, URI is enough.
Okay, I'm not finding my third class. Oh yeah. There we go, connection creator. Thank you, Ramnivas. My second set of eyes. So the connection creator, again, is a thing that takes the service info and creates the actual object that your application is going to consume. And in this case, it's this city repository object that we actually want our application to consume. So it's going to do this exact same feign code of just getting this URL from the service info that we built and passing it into feign, and then I can do this. So I have an app configuration class with a bean method in it, and it's going to get this city repository object and return it just by calling connectionfactory.service city repository.class. So this is the thing that wires it all together. So when I was building this, it kind of struck me a little bit, okay, I've got this one class that's just calling Feign and building it with a hard-coded URL that I could get from somewhere else. And now I've translated that to like 4 classes that just enable this. But the real value here is if you're building a REST endpoint, one of the best practices is to provide a language binding for whatever languages people may want to consume that service with. So if you're building a REST microservice backend, you might want to provide a Java library that makes it very easy to talk to that. And this is a really good way to do that. So I've got these classes in this application right now, but really if I'm providing this client binding library, all of this Spring Cloud extension code, like the web services info, the info creator, and the connector creator, would go into this library that you're providing, along with all the registration for it. You'll also see down here that I've got these 2 MED-INF services classes. So there's my service info creator being registered, and there's my connection creator being registered. So I can provide a jar file that's got these Spring Cloud extension classes and these MED-INF services files, bundle all that up as a jar file, and just by somebody linking that into their application, all this registration and discovery stuff is going to happen, and then the only thing that really ends up in the application is this one class that calls the connection factory to go get that. So that's really a nice way to package up a Java language binding to your backend REST service. Right?
So sort of the analogy would be if you're a database vendor, you would provide not only the database service, but also would provide a driver for it, right? So you would provide implementation where from application's point of view, that's all really matters. I get a data source, and I don't really care about the protocol or what does it even mean to basically talk to database. So that's the same here. So if you are a microservice provider, you would create microservice and create this library that can be consumed by Spring Cloud by just adding one line with that service method. So let's finish off this talk with talking about Spring Boot integration. This is very recent. It's only available in Spring Boot 1.2, which is in milestone now. And the idea is to make it just like everything that Spring Boot does, is to make certain aspects invisible. So you don't want to even have to deal with explicit configuration, even Cloud Scan. And let's talk about what it can do. So if you have Spring Boot 1.2 and you just add Spring Cloud dependencies on class path, that's all you have to do. You don't need configuration, you don't need Cloud Scan. Effect is the same as adding at Cloud Scan, but it will be taken care in the Spring Boot itself, right? So here, only thing that you have to do is add Spring Cloud dependencies. Well, not really. You could just add a Spring Starter, Spring Cloud Starter, and if you add this dependency, this is Maven example, Gradle, same thing, then it would pull in those dependencies, and then therefore we'll go back to the slide 1 with Cloud Scan being automatically happening. So this is really, really simple. If you are starting with Spring Boot, then you can start this way. It's a step up from auto reconfiguration. And then again, if you want to take control over it, then you can disable auto configuration for cloud and take control, the way other slides we talked about. So let's talk about what's next. We want to support all sorts of services, right? Some services are available in private cloud, Elasticsearch, Memcache, React, Cassandra, Neo4j, any other thing that may be thrown at us. So it's very easy. It usually takes, depending on the service. PhD took a little longer because it's a little bit more complex service. But if it is like a straightforward service like Memcache, it should take maybe an hour at most, including test suite. Speaking of which, Spring Cloud is extremely well tested. We got basically 100% test coverage. Because we kind of want to make sure that whatever goes into your runtime, because this goes as a part of your application, it better be robust. So we got a whole sort of tests that take case of all scenarios, if things are good and things are not good and so on. So support for other platforms. We currently support 3 platforms, Cloud Foundry, Heroku, and local config. We would like to support other platforms. What are those? Well, you tell us. What are the platforms you would like to deploy? Is it a Beanstalk? Is it Google App Engine? Raise an issue. If you can, make a pull request, even better. But pull request is not, it's a nice but not a must. If enough people are essentially saying support this particular platform, we can look at it. What about other frameworks? And frameworks is kind of loaded word here, right? We could support other frameworks as in not Spring framework. And again, what are those? You tell us. But more importantly, things like constituent frameworks like Spring Data is what we support right now. But are there like native drivers or native objects that you would like to be created? Still using Spring application, but not Spring Data objects. Again, suggest us what you want to do. Make a pull request if you can.
And a good way to think about this path forward too is if you look at the Spring Data and the Spring Social model, Spring Data, for example, has a core, and then it's got projects for JPA, MongoDB, Elasticsearch, all these things, and those sub-projects are different GitHub repositories. They weren't all built by Pivotal. The Elasticsearch one, for example, was built by people from another company, and they got it far enough along that it got contributed back to Spring Data, but it's not all one big GitHub repository with all that code together. It's all very modular so that it can be maintained by different people, and that's really the path forward for Spring Cloud as well. If we get a Amazon Elastic Beanstalk cloud provider or a Google App Engine cloud provider, that's not necessarily going to go right into the same repository as everything else. It should be more modular than that.
Right, so if you make a pull request and that pull request is of general interest, then we might take that pull request in. If not, we will actually point to your repository and sort of, so that if somebody is coming to Spring Cloud Connector repository, we will know that in case you are interested in this particular thing, then we'll essentially help you get popular through Spring Cloud as well. Right? So depending on what is appropriate for our users. With that, if you have any questions, we can take it at this point. Yes?
Do you have any information on that local cloud connector?
Yes, I don't have it in this presentation, but essentially what you end up doing is you have a property file, and that property file is going to list your URLs. And there is a particular format. So essentially you have name of your service.url, and then that's and then you point to the URL that you want to connect locally. Locally as in locally accessible. It could really be in a cloud somewhere out there, doesn't really matter. And that's all you really have to do, and then specify a property file as itself a property. And then Spring Cloud mechanism will kick in and saying, well, is it available? That property is available. If that property is available, then it will declare that is in matching cloud will come out to be true for that particular configuration. Yep.
Yeah, and we'll just point out that the GitHub repo for Spring Cloud connectors is now at this location. You can see the Heroku, local cloud config, and Cloud Foundry connectors and the Spring Service connector. There's really good documentation in the READMEs for each of those sub-projects in terms of how you consume them and how you extend them. So this is sort of the canonical source of documentation for the project right now.
Yeah, let me point to one more thing now that you're showing the URL. So the core project, we have been very cognizant of not having any more dependency than we absolutely must. So the core project has no dependency on any, it's just JDK. For testing, there is JUnit dependency, but for production, for runtime, there is no dependency other than just JDK itself. For Cloud Foundry, there is an additional Jackson dependency. For Heroku, there is no additional dependency because we don't need to parse anything. But these both projects do not have any Spring dependency. And this is the only project where there is a Spring dependency. So we kind of been very careful in terms of, we don't want to pollute your project with additional jar that you may or may not need. So we've been very careful about that. Yeah.
You were talking about the language bonder client. Do you have an example of that?
Language, sorry, what?
The language, you were talking about the language bonder. Is there an example of that?
Well, the example really should be extracting those Spring Cloud extension classes out of that UI project and making them a separate sub-project, which would be a good thing to do after this talk. All this source code will be available on GitHub. So we could pull that out and make that a little bit more clear how that would work as a separate jar file that you just include. So I guess we will have a good example of that once we do a little bit more work on the demo.
I guess it's going to happen next week.
Yeah.
Any other questions? Yep.
The cloud code does not even have Spring code dependency. You said it's just JDK. There's no Spring dependency.
The core project. Yeah, the core project has no dependency, but just no dependency, just JDK. Yeah. Yeah. All demos are available. Either it's in a Cloud Foundry samples demo, like the PhD demo is available in Cloud Foundry samples. Actually, it's in we'll make it available somehow.
They're all in GitHub repositories now, but they're scattered around a little bit as we've been working on the demos, so we'll pull them all in a easier to find place.
Yep.
So I saw that in the demos that they had like services that were late bound. Push the app and then you bound these services after the fact in the services. How does that?
So you're probably talking about essentially you push an application with no start. The reason is when you want to bind a service, you want to have application be there first, right? So what you have to do is you have to push an application, but because service isn't bound, you want to say no start so that application wouldn't start and fail.
No, actually it started out with the default of the in-memory.
Okay.
Yeah.
New relic or something that the application doesn't even know anything about.
Okay. So the question is, like how does New Relic come into picture, right, here, right? So in this case, New Relic, you wouldn't use Spring Cloud. It's really Buildpack's issue. Buildpack will, if you have bound to a New Relic service, then Buildpack will take care of adding additional hooks and Java agent or whatever else needs to be done. So you don't really know even that how is it being taken, how is it being done.
And I think the app that you saw was probably Spring Music app. So it's specifically coded to say, when I start up, if there's no database bound to me, it's using all the Spring Cloud stuff, but it's doing it a little bit more explicitly. So it says if there's no database bound to this application, I'm just going to use a hypersonic in-memory database. If there is a database bound to it, then I'm going to use that instead. So it's just getting one of several possible data source objects created different ways. So that's something that app does kind of special just because it's a kind of a first push demo app. These cities demos here, like the web backend, if you push it without a bound service, it's going to crash and say, I can't find a data source, just because it requires that up front.
So we provide DBCP. We provide Tomcat's high performance, which is really variant of DBCP. So those are the two ones we're providing, and there is one more. Wow, I have to. Sorry, what? Does it just depend on what you have your class path? Yeah, it basically has a priority. I can just quickly find out. Yeah, those are the two. Basic DBCP, Tomcat DBCP, and Tomcat High Performance DBCP. Those are the three ones. So those ones are the one that we look into each one. And each one basically say, is everything fine? You know, everything is on class path. Is it possible that I can create one? If so, then it has a priority. And there is actually a way to override. You can provide like, okay, if I have your own data source, then you have to give an environment variable. I forgot which one is it, but and then it will pick up that.
It's a very Spring Force, Spring Boot way of doing things. Inspect what's on the class path and use what's available.
Yeah.
It's a question related to Cloud Foundry. Do you know if Cloud Foundry is planning to support Docker containers?
.NET containers? Docker containers.
Loaded question. Yeah, maybe we can, we can answer that question really quickly. So the Docker picture is pretty nuanced, right? One part of Docker is this lib container, which is the actual implementation of the container mechanism. Cloud Foundry right now has its own Warden container, and the reason for that is Warden was created before Docker existed. We needed container technology, and so we built our own, and then here comes Docker later. So this lib container part of Docker could potentially replace the internals of Warden, but there's a functionality gap there right now that we're trying to work with Docker to close. So at that point in the future, when lib container is functionally equivalent with the insides of Warden, then we can adopt lib container underneath Warden. So that's one answer to that question. The other facet to that is you've got this Docker file, which is a mechanism for specifying a bunch of stuff you want to run in a container. Cloud Foundry supporting Dockerfile as a way to push something into Cloud Foundry doesn't really require lib container underneath of that. That can work on top of Warden just as well. So you will see Dockerfile support as a way to push applications into Cloud Foundry coming much sooner probably than the swapping out Warden internals for lib container. That's the quick answer.
All right, thank you.